Hi, my name is Ransom For, and in this presentation, I will be talking about copper and its very common and some specific applications, some real life examples, how it is being used for the greater good or for the benefit of the society. So at the end of this presentation, some of the few objectives I hope my viewers or my students should be able to understand is to be able to explain some of the properties of copper in relation to its structure or electronic arrangement. How does the arrangement or electronic configuration of copper influence some of the properties it exhibits? And then we will also uh, I hope you also get some of the widely used applications of copper in today's world. All right, so before then, I want to talk about briefly copper. Okay, copper is a reddish brown metal. It's very conspicuous. On the periodic table, there are only two metals. There are only two metals that that have a color that stand out. Almost all the other metals they have a silvery appearance for the exception of copper and gold. Copper and gold are the two metals that have colors that stand out. And copper is a reddish brown metal, very conspicuous. Looking at it, you cannot miss because of its color. So it's a D block transition metal, also called uh, a a transition. Is they are also called the D block element. So copper is a D block element and it's a transition metal with atomic number 29. Uh, it is extracted through thermal reduction of the very common ore copper pyrite. It has some of the properties that other metals exhibit, like malleability, ductility, and it's an excellent conductor of heat and electricity. It is worth mentioning that copper is only second in conductivity to silver. It is an excellent conductor. It is the second best conductor that we have. So now let's talk about some of the applications, the very common applications of copper and its alloy. So copper and its alloys, they have a wide variety of application. Characteristics such as strength, conductivity, corrosion resistance make copper and its alloys suitable for a variety of application across the board. So copper's conductivity is second to silver, as I mentioned earlier, and is so why do we prefer copper to silver, despite silver being a better conductor? The reason is for the purpose of wide application and wide use. Silver is much more expensive. Copper is much more available and much more affordable. So because of the cost effectiveness factor, copper is preferred for electrical wiring and for uh, this application or for this purpose because of its affordability. It's cheap. Copper is also used as tubes for plumbing, partly because it is a non-toxic metal and also because it is malleable and affordable. So in house construction today, we use copper. And this application, you will notice in developed worlds like the United States, Canada, Germany, uh, copper is they're kind of phasing out copper and replacing them with much more better material like polymers. But you will find this application being widely used and explored in developing countries. In third world countries, they still use copper for these purposes, like for plumbing pipes to transport water and all of that. But in developed countries, copper is mostly used to transport oil and gas and transport other stuff other than water. Also, you have copper, that is copper and its alloy, because they are kind of steam and freshwater resistant, which means they wouldn't easily corrode in the presence of steam and fresh water. They will resist to corrosion from marine and in any industrial atmosphere. This makes it suitable for the building of pipes offshore for the transportation of oil and gas. Okay. We also have another widely used application of copper, and that's most especially in the United States. For many years now, the 1 cent coin was made up of copper. It was mostly made up of copper, especially coins that were made before 1980. Coins that were made before the 1980 were predominantly made up of copper. But after the 19, especially after 1982, the composition of the coin was changed to be made up of now copper and zinc. Uh, and that change was made to reflect the value of the coin, which is 1 cent. So again, it's worth mentioning that the composition of the 1 cent coin has changed over time. Over time, this composition has actually changed. Copper is widely used in automobiles. In the construction of cars, you have so much copper, right? That plays a role in that construction. Copper is a key component of motors, radiators, brakes, wiring, bearings of vehicles, and all of that. It's even estimated that a modern Tesla vehicle is made up of about 55% copper. So copper is an important uh, component, it's an important metal in the construction of automobiles. All right, so if I were to teach this to my students, the instructional component, the way I will structure it is I will first of all talk about copper, right? Its extraction. So what I will do is I will first of all talk about the location of copper in the periodic table, talk about the metallic bonds that copper exhibits, because most of the properties that copper exhibit are as a result of its metallic bonds. So copper is in the same group as silver and gold in the periodic table. So copper has a S subshell that's filled with one electron. This allows it to form metallic bonds. The formation of the metallic bonds makes copper a malleable metal, right? The metallic bond is also responsible for the electrical conductivity of copper and its high thermal conductivity. So talking briefly about copper, copper is a prehistoric metal because there has been some copper, right, that was discovered in what is modern day Iran. That dates back as 9000 BC. That is a lot of time uh, from today. So copper is a prehistoric metal. It's a metal that was used, that had application since uh, more than 10,000 years today. Okay. So before the 1980, as I mentioned earlier, the 1 cent was made up of pure copper, and then that composition changed over time. Now, teaching about the extraction of copper, I want my students to understand some few equations, right, that leads to the formation of copper. So copper, if you look at these equations, copper is being extracted from a main ore that we call copper pyrite. So what happened is that this ore is usually concentrated by float flotation. So we concentrate the ore, and when we've concentrated that ore, what we do is that we roast this ore in air. So in the presence of oxygen, this ore is being roasted. So when it's roasted, it is going to form copper 1 sulfide, iron 2 sulfide, and sulfur dioxide. So also you have silicate. Okay, so sand, which is also called silicate, is added to the blast furnace because the instrument that is used in the extraction of copper is a blast furnace. So we add the silicate in there, right? That silicate helps to combine with the iron 2 oxide uh, to form iron silicate, right? So that is going to be removed in the form of iron silicate. Okay. So now you roast now you react the copper 1 sulfide with oxygen, and that is going to form uh, the oxide. So that oxide now is being reacted. So we have a self kind of reduction. Iron 2 oxide reacting with iron 2 sulfide to form the copper. So these are the equations that summarize the formation of copper in the blast furnace. And I want my students to grab that concept. So now I'll talk about the other instructional component I want to talk about here is the metallic bonds of copper. So if you look at the electronic structure of copper, you realize that it has one electron in the s subshell, and so that electron allows it, right? When the copper atoms come together, this one electron will share space with the neighboring atoms in such a way that the sharing occurs with the central atom and the 4s orbital on all of the 8 copper atoms. Again, when I'm talking about all of the 8 copper atoms is because copper forms a face cubic center structure such that if you have a copper at the center, right, you will have 8 neighbors. So every copper is located in such a way that it has 8 neighbors around it. So when the 4s of one copper, it is going to share space with those 8 neighbors in such a way that they will now form a cloud, right? They will form a cloud of electrons, and this cloud of electron is going to be surrounded by stationary positive nuclei of those copper atoms. As this picture shows, this is how a metallic bond is formed. So they form a sea of delocalized electrons. This structure is responsible for explaining all the properties that coppers exhibit, right? When it's malleable, malleable means that it can be changed into various shapes. If we hammer a piece of copper, it doesn't break because the copper atoms simply rearrange themselves. They have the ability to rearrange themselves. For ductility, again, because these atoms have the ability to slip over one another, you can pull copper into a wire. That's the meaning of ductility. You can pull them into a wire, right? These copper atoms, they act like some cushion so that when the copper is hammered, for example, the structure does not change because the atoms simply rearrange. I hope that is understood. Okay, so the sea of electrons are free to move. They are free to move all over the structure. And that is why copper is an excellent conductor. Remember, conductivity is the movement of charges. Okay, so what are the charges that are moving in this case? The electrons. So in a copper metal, the particles responsible for conduction are the electrons. Okay, so the electrons, because they have the ability to move, they will carry the charge along. They will transmit that charge along. Okay, all right. So that's that for the instructional component. Okay, that's that for the instructional component. Now, I also did analyze I also did analyze two articles, and these articles were trying to explore copper for the greater benefit of the society. So the first article that I did analyze, the title was "The Responses to Tomato Plants Under Saline Stress to the Foliar Application of Copper Nanoparticles." So I just want to summarize this. I just want to summarize what the result of my findings, and how copper was used in this application. So what happened is that the tomato crop has a huge impact in our economy today. So this study was conducted by Perez Labrada et al. So on the salt stress that adversely affect tomato plants. So the objective of the research was to measure and quantify the agronomic and biochemical response of tomato with foliar nanoparticle. So the copper nanoparticle with and without salt stress was used in the study. The study revealed that soil stress can be very damaging to the growth of tomatoes, but when we apply copper nanoparticle, it helped to alleviate, or it helped to mitigate the damage that is being caused to tomato. Right? So tomato, the growth of tomato here can be saved, or can be what will I say? We can have a best we can have a better production when we apply nanoparticle to tomato. That's the way I would summarize it. So when the application of nanoparticle, it was shown by this study that the application of nanoparticle increased the growth performance by improving the sodium to potassium ratio. So when you spray tomato with copper nanoparticle, right, it actually makes the tomato, it induces in the tomato a higher tolerance for salinity. So the salt stress wouldn't affect or damage it that much in the presence of copper nanoparticle. So that was an important conclusion in this research. So this is another one more use, right? That shows how useful copper is for the greater good of the society. Remember, tomato is a very important crop, right? It's a very, very important crop. And so copper nanoparticle helps to improve the growth of that. So let's move to the second article. So with the second article, again, I analyze the application of copper nanoparticle and potassium silicate stimulate the tolerance of Clavibacter michiganensis. That's michiganensis in tomato plants. Again, this study was on tomato, but this time around it was on a certain pathogen. Okay, the pathogen that we call Clavibacter michiganensis. Right. So how does copper help tomato to fight these pathogens? How does copper help tomato, right, to resist the attack from this pathogen? So this article was conducted by a group of scientists led by Cumplido Nahera et al. So it talks about the research was conducted on tomatoes. They study the damage caused by pathogen, especially Clavibacter michiganensis. So the science and advances in nanotechnology has provided alternatives that could be used to control pathogens responsible for destroying tomatoes. So the research studied the effect of copper nanoparticle and potassium silicate on the tolerance of Clavibacter michiganensis in tomato. And so the most important part of this is the result of that research. So the result of the research showed that copper nanoparticle, when used in conjunction with potassium silicate, was very effective at mitigating the severity of pathogens. So these pathogens wouldn't affect the tomato that much, especially Clavibacter michiganensis. And so, in terms of statistics, or in terms of the effectiveness of copper nanoparticle, when applied in conjunction with potassium silicate, it was showed, right, that in a quantitative manner, the loss as a result of the bacteria was reduced by 16.1%. That's an amazing figure. So imagine that without the copper nanoparticle being applied to the tomato, the production they will have lost as much as 16.1% of their production. I think that's a significant figure. That's huge. All right, so that's another great example that depicts the widely used application of copper. Okay. All right. So thank you, because we've come to the end of this presentation. But before we go, I want to express gratitude to the following sources, without which this work will not have been possible. So I want to express an in-depth of gratitude. Again, thank you for your kind attention, and I hope you had a nice presentation.